Hey guys, my name is Kelly.
I'm Jennifer.
My name is Fadi.
And we're Team FJK.
We worked on the Steganography project.
And we'll show you guys how our GI works.
This is our flatten function. The flatten function takes an image as an input and assigns a value of 0 or 1 to each element of the image. Whether it assigns a 0 or a 1 to an element depends on the value set to the threshold. In our function, we set the threshold 165. If the value stored in an image element is greater than 165, it's assigned a 0, and if it's less than 165, it's assigned a 1. The result is a flattened image containing zeros and ones.
This is our expand image function. We use this function within our recover methods to extract the hidden image. It takes in a flattened image and outputs the expanded 3D matrix. We first made a 3-layer array of zeros and extract the first layer of that array. Then we check each element in the flattened image, so if the pixel is white, the corresponding element in the first layer of the zero array is black. If the pixel in the flattened image is black, the corresponding pixel on the zero array is white. The layers then make up a 3D array.
This is one of our hide, odd, and even functions. This function corresponds to the blue layer. In this function we use the odd and even algorithm to embed the image into the dog image. So the way it works is that we extracted the blue layer and then we created an array of zeros that's 400 by 400 to store the image on. And then, so if the mod of the blue layer is divisible by 2, which means it's even, we make the flat pixel that corresponds to 1, which is the white pixel, we make that equal to the blue pixel. If it's not divisible, then we make the embedded blue, we make it 1. And then if it's divisible, then we subtract 1 to make it even. So that's for the first divisible by 2. If it's not divisible by 2, which means it's an odd pixel, we take the flat pixel and check if that corresponding pixel is equal to 1, which is a white pixel. Then we subtract 1 to make it even, and otherwise we just keep it the same as the corresponding blue pixel on the dog image. And then after that we save the embedded blue image into the third layer. For the recovery function, we took the blue layer that was embedded and then created a recovery array that's 400 by 400, all zeros, and then we reversed the process of the first function. So we basically checked if the blue embedded image is not divisible by 2, which is odd. That means we assign the recovered corresponding array that we created to 1, which is the white pixel. Otherwise we assign it to 0 for black pixels. And then in the same function we sent the recovered array to the expand image so it's displayed in the right form.
This is one of the 12 embedding functions that we created. This particular function takes the pixel index and divides it by 3. If the pixel index is divisible by 3, then the program proceeds to check the value stored in the flattened image at that index. If the value is 1, the information is stored in the red channel. If the value is 0, the pixel information is stored in the green channel. Similarly, if the pixel index is indivisible by 3 and gives a remainder of 1, then the program checks the value of the flattened image at that index. If the value is 1, the pixel is stored in the blue channel, otherwise the pixel is stored in the red channel. The last outcome is that the pixel index is indivisible by 3 and the remainder is 2. If the value of the flattened image at that index is 1, then the pixel information is stored in the green channel, otherwise the pixel information is stored in the blue channel. This is the recover function for embed 2. It starts off by separating the embedded image into 3 layers. If the pixel index is divisible by 3, the function proceeds to check the value stored in the embedded image at that index. If the value gives a remainder of 1 when divided by 3, then the recovered pixel has a value of 1. If the value gives a remainder of 2 when divided by 3, then the recovered pixel has a value of 0.
This is another embedding function we made. It's written in a similar way as the even-odd embedding for each layer except with different divisor. In this function, the divisor is 4. We are able to make this function for each layer of the RGB image. This particular one is for the green layer. We start by extracting the green layer of the dog image and go through each element. It divides the pixel number by 4 and takes into account each of the possible remainders, which are 1 through 3. A 0 array is made so that all changes will be copied into that array. This will turn out to be our embedded layer. The changes made basically make all the pixels divisible by 4 by subtracting the remainder. The layer is then put back as the second layer in the RGB image. The same goes for embed green 5 function, except that the pixel is made to be divisible by 5 and the remainders are subtracted for each pixel. We are able to do this embed green 4 and embed green 5 on the red and blue layers with some modifications. This is the recovery method for the embed green 4 function. In this recovery, we extract the second layer of the embedded dog image and also create an array of zeros. For each element, if the pixel is divisible by 4, and it will have a 0 remainder. So it converts the recover matrix pixel to 0 and the white to 1. Afterwards, the image is expanded to reveal the hidden image. Our recovery for embed green 5 is recover green 5, and just like the recovery for green 4, it's the same except our mod is with 5 now. So it divides all the pixels by 5 so that it changes the pixel color in the recovered image. We then expand it like the other function to reveal the hidden image.
So this is our GUI. I'll show you guys how it works. First you run it, and then you load the image, the dog image, and then you pick one of the images that you want to embed in the dog image. And then after that you pick the technique you want to embed it with. So let's say I'm gonna go with blue, and then so this image now is embedded inside that one, and I'm gonna save it. Just keep it as embedded image and save it, and then I'm gonna load that image. And so now if you select a different technique to recover it with, it tells you that you're selecting the wrong recovery method, which means you cannot recover the image with that technique. So you have, if you select green, let's say, it won't let you any of the other techniques. It won't let you until you select the right one, which is blue. It says your image has been recovered, and it shows you the correct one. You can clear it from here just for this one, or you can clear all from here. And also if you click on instructions, it'll show you how to use the program. So we can just try another technique. Let's say we pick image 6 and let's embed it with the red mod 5. Save that, and then load the saved image. And so let's try this. It won't let you, say you are selecting the wrong technique. So until you select the right one, which is the recover mod 5, it shows you the one you selected. And I also added the feature that you could take a screenshot. So you click on that and it takes a screenshot of the whole thing, and that would be saved under screenshot right here. And that's pretty much it for our GUI.